Assalamualaikum everyone. The third session of O-level math, vector geometry. For example, we all know that a vector is a line which has a magnitude as well as direction. We have studied thoroughly the concept of column vectors. We have done a lot of questions on those past paper questions related to column vector. So now it's the turn of the other part. That other part is something like this. For example, if a vector is A, another vector is B, and I can add both the vectors, the head to tail method. This is A, this is B. Start till the end. That is A plus B. So that's how you add the vectors. Similarly, I could have first drawn B and then drawn A. The resultant, the final vector, the shortcut from X to Y will be the same. For example, if I want to add A minus B, so this is A, this is B. Therefore, minus B is in the opposite direction. So minus B goes like this. So A minus B is actually A plus minus B. In vector, we always do addition. We can change the sign of a vector. We can reverse it. The magnitude will remain the same. The direction would reverse. And now I can add it up. That means this would be A, more or less like this. This is a rough diagram. And minus B is going like this. That means start till the end. This is A minus B. So we have seen the addition of vectors. We have seen the subtraction of vector. Subtraction is actually addition with a negative vector. This was the basic. This was the second page of the basic. Now let's look at this diagram. The diagram shows vectors A and B. So this one is A. This one is B. Find OP and OQ such that OP is 3A plus B. So OP, it's 3A plus B. That means 3A would be 1, 2, 3 in this direction. So this is like 1A, 2A, 3A, and B is just one unit. That's in this direction. So 3A plus B, this is the resultant vector. Start till the end. The green one is the resultant vector, 3A plus B. That is OP. The shortest distance from O to P is OP. Now, what's the other one? That is OQ. OQ is minus 2A minus 3B. That means A is going up, so minus 2A is this one. Minus 3B is this one. 3 times B, but the direction is reversed. Therefore, start till the end. This is minus 2A minus 3B. This is the vector. So that's how you do this basic addition, subtraction of vectors. And of course, the scalar multiples are also involved. Now let's look at this grid. It says in question 1 to 26, use the diagram below to describe the vectors given in terms of C and D, where C is Qn. So this is C, and this is D. This is the vector D. This is vector C. This is vector D. Now, for example, I need these following, so many vectors. Okay, let's just pick a few of them. Let's pick KH. So if I want to go from K till H, that is only in the direction of D. So that's a D, another D, another D. So I can write KH is 3D. Done? Similarly, if I need one of the vector XM, I'm picking this one up, XM. That means I have to start with X and go till M like this. So XM is along the D direction, it should be minus D. This one is minus D. And along this direction is 1C and 2C. So it's 2C in this direction. Therefore, XM is minus D plus 2C, which can also be written as 2C minus D. So this is the basic of vectors. Similarly, if I need EV, this one. So EV is going from E till V. That's a long way. This is E till V. This is the resultant. That means first go in the direction of C. So this is 1C, this is 2C, this is 3C. Of course, 3C with a negative sign because you are going down. So this is negative 3C. And then this is D, 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 3 Ds, 4, 5, 6. So that is minus 60. Therefore, EV is minus 3C minus 60. That's it. Okay, now let's move on. Let's move to this question. The vectors are given as follows. Find BA. Now, how can I go from B to A? B to A is negative A. How can I go from A to C? A to C is, you have to go all the way around. A to C is this resultant. Therefore, for part B, AC is in fact AB plus BD plus DC. AB is A, BD is B, CD is 2A, so DC is minus 2A. So therefore, this comes out to be B minus A, that is AC. It is simple addition, just like the concept that we learned in column vectors. Part C, DB. DB is minus B. BD is B, DB is minus B. What about AD? AD. Go from A till B, then go from B till D. The shortcut is AD, that's A plus B. Straightforward. Have a look. Let's move on. Something like, let's look at this one. 42. FE. FE, how do you reach FE? Part A. F till E, that is going FA plus AB plus BE. FA is B, AB is A, BE is minus 3B because EB is 3B. So BE is minus 3B. So that is the shortcut from F to E. So this is A minus 2B, that is FE. Similarly, if I need BC, BC is CD plus DE plus EB. CD is 2B, DE is minus A, and EB is 3B. So that is 5B minus A. Third part, FC. FC is FA plus FB, FA plus AB plus BC. That's FC. That would be going like this. So therefore, FC would be FA is B, AB is A, BC, I think we found earlier, that is 5B minus A. So therefore, AA would cancel, and this would come out to be BC is 5B minus A. So therefore, this would come out to be 6B. Let me just double check. This is FA is B, and this is A, and this is BC. BC is CD. CD is minus 2B. Now, wait a minute. There was a mistake. Let me correct it. CD is minus 2B. So we have to go back all the way. How do I know that I made a mistake? I did not look at the answer. Let me tell you this. CD is minus 2B. And DE is minus A. And EB is 3B. EB is 3B. So BC is B minus A. And third part, coming back to it, that is FC. FC is like this. This is not parallel. This is equal to FA plus AB plus BC. FA is B, AB is A, BC is B minus A, AA cancel, that comes out to be 2B. And D, the D part is DA. What is DA? Going from D till A. So this is something like this. That is the approach. DA is DE plus EF plus FA. DE is minus A. EF is found out. This is FE. So EF would be opposite of that. So it should be minus of FE. Let me write it in step. Plus FA. What is FA? FA is B. So this is minus A minus FE is A minus 2B plus B. This is minus 2A plus 2B plus B plus 3B. So that's how the working is done. Okay, let's move on. In a triangle OAB, OA is A, OB is B, M is the midpoint of OB. Remember, we talked about M also earlier on. When we talked about M, we said that if I use coordinate geometry, if A has coordinates x1, y1, B has coordinates x2, y2, then the midpoint M has coordinates x1 plus x2 divided by 2, and similarly y1 plus y2 divided by 2. Therefore, we generalize this rule that OM is basically half of OA plus OB. OM is not half of, it's in this case, it's half of OB, but general rule is this thing. Now, it says, they're asking the following. They have given us what? They have given us OA is A. So OA is A and OB is B. So this is A, this is B, M is the midpoint over here. And then it says, find AO. AO is minus of OA, which is minus A, makes sense. find OM. OM in the scenario. Okay? That's the general rule of OM. If OA and OB are given, if M is the midpoint of AB. If this is A, this is B. So remember this rule that OM is half of OA plus OB because according to the midpoint formula. In this question, you cannot apply whatever you have learned earlier without looking at the diagram, because now M is not the midpoint of AB, M is the midpoint of OB. So OM is simply half B. And what about AM? AM is this thing. That means OA plus AM is equals to OM. That's one way. OA plus AM is equals to OM. Therefore, AM is OM minus OA. OM is half B and OA is A. That's one approach. The other approach is just take the direction like I was doing in the previous questions. You can write AM is simply AO plus OB. AO is the answer of the first part, which is minus A, and OB is OM, not OB, AO plus OM. AO is minus A and OM is half B. So this is half B minus A. Of course, both answers are the same. Have a look. Now let's move on. Now look at the first question. ABCD is a trapezium. AB is given as 4P. AB is given as 4P. Okay, this is given. And AD is given as Q. DC is given as P. Write down in terms of P and Q, CA, CB, and BD. So CA, that is this line. What is CA? CD plus DA. CD plus DA. What is CD? Minus P. What is DA? Minus Q. So this is minus P minus Q, that is CA. What about CB? How can I find this? I can use this newly found CA, that's one approach. So I can say CB is simply CB is CA plus AB. What is CA? Minus P minus Q. What is AB? Plus 4P. So therefore, this is 3P. This simplifies to 3P minus Q. That's one approach. Otherwise, the alternative approach was I can go from C to D, D to A to B. So CD, alternative approach. Let me just cut paste. CB is going this way, and then going down, and then going to the right. So therefore, CB is CD plus DA plus AB. CD is minus P, DA is minus Q, and AB is plus 4P. 4P minus P is 3P minus Q, which is the same answer as before. This one. The last part, BD. Now, how do I go from B till D? BD. Therefore, BD is BA plus AD. That's it. That is BD. What is BA? Minus 4P. What is AD? Q. That is Q minus 4P. Now, that is the first major question. Wait a minute for a second. Okay, let's move on. Let's try this one out. In the triangle OBD, OA is A, is 1/4 of the length of OB. Okay. OA is A. That means this much is A. This much approximately is A again. This much approximately is A again. It's not drawn to scale. Let me just make it a bit bigger. This is A. This is another A. And let me add one more A. So there are 4 A's along this line. That is the concept. OA is 1/4 of OB. Let me write it another way. OA is 1/4 of OB. Where does it say? It says over here. OA is 1/4 of the length of OB. Therefore, OB is 4 times OA. That is 4 times A. That means the whole OB is 4A. So therefore, there is 1A, there is 2A, there is 3A, there is 4A. That's how the logic is. Similarly, it says OC is C, is 1/3 the length of OD. OC is C, is 1/3 the length of OD. So therefore, this is another C, and that's another C. So this is C, this is C, this is C, 1C, 2C, 3C. OC is 1/3 of OD. In other words, OD is 3OC, that is 3 times C. So OC is full 3C. What else can I get from here? What I can get is that AB is 3A. I can get CD as 2C. And now it says E is the midpoint of BD. That means whatever this vector is, this red vector and this yellow vector is the same because it's the midpoint. So this vector, whatever that is, let me call this thing as U. So this vector would also be U. The reason why I'm not calculating is for BD, you have to do addition of these vectors. OB plus BD, OB plus BD is equals to OD. OB is 4A, BD is what you're looking for, OD is 3C, therefore BD is 3C minus 4A. Done? I think we have found almost everything related to it. They're asking for OB, they're asking for OD, they're asking for AB, done, CD, done, BA. BA is negative of AB, AC. OA plus AC is equals to OC. We can do it. AD. OA plus AD is equals to OD. BD. OB plus BD is OD. We just found it. OE. OE plus ED is equals to OD. CE. CE plus ED is CD. So basically, it's about playing with the alphabets. That's what vectors is all about. That is the beauty of vectors, whether you appreciate or not. So the thing is, that's how vectors is to be done. Okay. Now let's move on to this question, a question which involves a hexagon. Now it says A, B, C, D, E, F is a regular hexagon. M is the center of the hexagon. AB is equals to P. That I can see this AB is P. Now let me first label what else could be P. Since it's a regular hexagon, all the 6 sides are equal. So lengthwise, AB, BC, CD, DE, EF, and FA, they all are equal. Now another issue. Angles at a point add up to 360 degrees. So if this is 360, therefore each angle is 60. These 2 sides are also equal. Therefore, these 2 angles are also equal. Therefore, all these triangles are equilateral triangles. Done. That's a property of a hexagon. What else can I label? Excuse me. I can label all those which could be P. That means, let me remove the angle. This could be P. This could be P. Because you can take vectors anyway. This could be P. So this is P, this is P, this is P. What about R? This is R, this is R, this is R, and this is R. So this is R, this is, let me label it with some other marker. This is R, this is R, this is R, this was the original R. What else is left? Q. This is Q, this one, and this one. So therefore, this is Q, this is Q, this is Q, and this is the original Q. That's how you have labeled everything in a hexagon. Done? Now they're asking for DE, AC, and so on. Let's start with DE. DE is simple, that is minus P. How would you calculate AC? AB plus BC is AC, AB is P, BC is Q. Therefore, AC is P plus Q. What about FA? What about FA? FA is minus R. What about AE? How will you go from A till E? A till F, F till E, that is AE. Listen to it again. A till F, F till E, that is AE. And then it says, using vectors, show that FD, where is FD? FD, okay. That's the same thing as AC. We will show it shortly. Write down in terms of Q and R, AM, okay, and MB, and MB, okay. We'll also see to that. Write P in terms of Q and R. So now this is a fully involved question. You have to go step by step. Now, let me first take a snapshot from my phone so that I don't have to flip the pages. And let me move to the next page. I need maybe 2 more pages for like this. A big diagram is good enough. Now, this is, first of all, I'm looking for DE. For DE, that is straightforward. ED is P. So therefore, A part 1 DE is minus P. Second part, it's asking for AC. So AC is this vector like this, that is P plus Q. So AC is AB plus BC, that is P plus Q. Third point, FA. FA, AF is R. So AF is R, but FA is minus R. Fourth part, AE. AE, which one is this? A till E, like this, all the way up. This AE is AF plus FE. AF is R and FE is Q. Done. Now it says using vectors, show that FD is AC. Show that vector FD is the same thing as vector AC. Now FD is this vector, like this, and AC is this yellow vector. Now we have already found out what is AC. AC is already known. AC is this P plus Q. Now we know this, that FE is Q. So FD is FE plus ED, that is Q plus P. This is P plus Q. And of course, we know that Q plus P and P plus Q is the same. Therefore, we have proven that vector FD and vector AC are exactly the same. Done. Now it says, write down in terms of Q and R. Let me move to the next page. They are asking, in terms of Q and R, part C, that is AM. Now AM is Q and R. AM, isn't it the same thing as BC? So AM is the same thing as BC. Therefore, AM is Q. And part 2, that is MB. How can you find MB? A, this is Q. So AM, they're asking for MB. This is Q. So therefore, AM plus MB is equals to AB. MB is AB minus AM. What is AB? This is P. What is AM? That is Q. So that is P minus Q. What else is there? Now it's asking, write P in terms of Q and R. Now, can I find AM in terms of P and R? Can I find AM in terms of P and R? Let me label all the angles. This thing is R. This thing is P. And what else is there? This is P. This is P. This is P. MB is there. And they're asking us, write P in terms of Q and R. Now, what's the relation between P, Q, and R? Pick any triangle and you can see the relation. For example, if I say AF plus FM, that is AM. AF plus FM is equals to AM. This thing is this thing. AF is R, FM is P, AM is Q. Therefore, the relationship between P, Q, and R is this thing. Now, if someone would have asked, write MB in terms of Q and R, we found MB to be P minus Q. Agreed? But I don't need P. I need to replace P. So what is P equals to? Q minus R. So P equals to Q minus R plus minus Q. Therefore, MB is simply R minus R, which makes sense. Because if this is R, if this is R, therefore MB, BM, first so many letters to look at. BM is R, therefore MB is minus R. So you can also do it like this. Okay, that's with this question. Have a look at it more comfortably. This was the first page that we started with, the first page of this question, labeled all the angles. Then we were working on this, finding DE, and then AC, FA, AE, show that the two vectors are the same, FT, this vector and this yellow vector. We already found what is AC. We just have to find out what is FT. Head to tail method. That is the key for success. Done. Now on this page, MB. I could have found it directly also, but I was thinking in terms of addition of vectors. AM plus MB is AB. AF plus FM is equals to AM. I'm finding a relation between PQ and R. I can find from any one of the triangles. MB in terms of Q and R, and maybe just one of the alphabets. MB is P minus Q. P is Q plus R. Q minus R. Therefore, MB is minus R, which can also be obtained directly. Because BM is R, therefore MB is minus R. Okay, one more question. I think we should do this one. WXYZ is a parallelogram. And then it says, WX is U, that is this vector. What is the definition of a parallelogram? Opposite sides are parallel as well as equal. WZ is V. That means XY is also V. Let me just mute the voices. Okay, what is the other one? WX is U. What else is U? ZY. Okay. Then they are asking the following. Let's first find that. They are asking what is WY. First one is straightforward. WY, let me make it a bit smaller. Part 1, WY is basically WX plus XY. Wx is u, and xy is v. The second part, Wm. M is the midpoint. So Wm is half of Wy, that's half of u plus v. Third point, Xw. Xw is minus u, simple. Xz. Xz is Xw plus Wz. Xw is minus u and Wz is v. So this is minus u plus v. You can also write this thing as v minus u. Show using vectors that M is the midpoint of Xz. Show using vectors M is the midpoint of Xz. That means I have found out what is Xz. That means, can I find out what is Xm? I can find out what is Xm because I have Wm. So therefore, let me increase my working. Let me put it on the side. So therefore, I can put it somewhere here. Okay, that's neat. Now, what I can do is that going from X to M, Xm is Xw plus Wm. What is Xw? Minus u. What is Wm? Wm is half u plus half v. That is half v minus half u. Okay. Now, what should I do? I have Xz. I have Xm. If M is the midpoint, of Xz, then it's necessary that Xz should be half of Xm should be half of Xz. This is Xz, and half of them should be Xm. So therefore, what is half of Xz? What is Xz v minus u? Isn't this answer and this answer the same? Yes. Whether you find Xm directly or you apply the concept that M is the midpoint of Xz, you are getting the same answer. Hence, you have proven that M is indeed the midpoint of X and Z. And it's a rule that we study in ADMATS, that if it's a parallelogram, the diagonals have the same midpoint. What are the different shapes of a parallelogram? It could be a parallelogram, it could be a rectangle, it could be a square, it could be a rhombus. Now,